Today, our topic is: why do some factory acceptance tests fail? The hidden risks in automated equipment projects. Why some factory acceptance test FAT fails, even if the equipment seems to be working properly. The problem is not usually the machine itself. The real problem is the key risks were not identified before or during the process. Many companies think that is just a simple device verification step. The equipment has a running test report and complete acceptance documents signing. However, a professional factory acceptance test is not just to prove that the equipment can operate. It is a structured risk control process to verify the equipment process, materials, and production conditions are truly ready to ensure stable manufacturing. This is exactly where many automated equipment projects face hidden risks. The first hidden risk is the project enters FAT before it is truly ready. In non-standard automated projects, equipment development is usually associated with product development. However, many projects, when important input conditions are still changing, start the FAT. For example, the customer's product has not been fully determined, and manufacturing processes are still being optimized. The software is still in a modified state, and mechanical improvements are still ongoing. When this happens, FAT is no longer a real acceptance test. It becomes a combination of testing and engineering development. The customer thinks they are accepting a completed device, but the supplier thinks they are still completing it. This difference will cause future delivery issues. The second hidden risk is using the wrong materials during the FAT process. Automation equipment are always designed around a specific product. Test materials are not just a product sample. It is a key part of the verification process. However, in many projects, suppliers use temporary samples during temporary samples. The problem is temporary samples may not represent mass production. A small difference in the product under conditions may cause a major automation problem. Changes in size may affect positioning accuracy. Material changes may affect clamping performance. Packaging changes may affect feeding and handling systems. If FAT uses untrue materials for testing, test results may produce false information. The equipment passed the test, but production risks still exist. The third hidden risk is lack of the right personnel during FAT process. A typical FAT includes suppliers, engineers, project managers, and technicians. But for a successful FAT requires more than just technicians. The production team needs to confirm whether the operators can use it. The quality team needs to verify whether the output results meet the standards. Process engineers need to confirm if the manufacturing process is stable. Maintenance team needs to assess future service needs. If only purchasing representatives are involved, that the equipment meets the contract, but cannot confirm whether the equipment can support long-term production. The fourth hidden risk is the factory environment. The difference between the real production environment. Many FAT tests are conducted under ideal conditions: stable temperature, clean environment, controlled operation. However, the customer site may have completely different conditions: dust, temperature, humidity, production pressure. If FAT environment does not represent actual operating conditions, may remain until hidden. The equipment is installed. Industrial equipment is not designed for real factories. A real project case display shows how these risks combine together. A customer purchased an automated production line. The technical agreement has been completed. The customer's product is still in the development stage. There is no final production sample. Process requirements have not been fully confirmed. Quality standards have not been frozen. Temporary products were used for testing. The equipment can run successfully. However, the FAT results do not represent mass production. After installation, different real production additional adjustments are required. The problem is not just about equipment quality. The deeper problem is the project. Before the project itself is not mature enters the FAT stage. So, what constitutes a successful factory acceptance test? A professional FAT should control 5 key personnel. Whether the right personnel are involved in the second. Equipment, whether the equipment is complete and ready. Stable. Third, materials, whether the test materials represent future production. Methods, test procedures, and acceptance criteria. Fifthly, whether the test conditions match the real factory. When these 5 areas are controlled, FAT is not just an acceptance condition, but a powerful risk prevention process. for companies that purchase automated equipment, especially from overseas suppliers. But also purchasing equipment from overseas is not just to make a machine, but also to control uncertainty before delivery. To control uncertainty, a strong FAT process can help identify risks earlier, reduce project delays, but also to manage the risks behind the machine. Because a successful equipment delivery is not just about manufacturing a machine, but also managing the risks behind the machine. If you want to learn more information about industrial equipment and factory acceptance best practices, please click the link below to read the full article.